So, hello everyone. I'm John Rattz. If you haven't met me, I'm from Analytical Mechanics Associates, working for Digital Earth Africa in this case. And we're going to be talking about using something called Dask for the Open Data Cube. So first off, what is Dask? Dask provides a means of analyzing data sets larger than memory, so more than we can fit in what the instances we have on the sandbox, on the Digital Earth Africa sandbox, using all the processors on a machine, all the CPUs. And it can actually run with a cluster of machines even if we wanted to scale further. So this is kind of future-proof. Normally, you only get to use one processor on a machine, one CPU. On Digital Earth Africa, though, we have two. So even on the default instances that we use, this can be useful. More significantly for us, Dask provides an array data type that can be used by X-ray dataset objects returned by our loads. So we'll get to more of that in a second. We'll mention what that means. So first, what Dask does. It allows us to work with more memory than is available in an environment by breaking our work into smaller chunks. So instead of loading one large contiguous amount of data, it loads smaller pieces and works on the pieces together to get you the end result that you ask for. Dask allows us to use all the processors on a machine to perform the same task faster, and this is called parallelism. It's especially useful in large instances with multiple CPUs. So what Dask really does is it breaks what you load into smaller chunks, what you have to do into smaller chunks. And these are parallelized based on what you're asking. So it can be fairly complicated in what exactly it's doing, but you may think, for example, one example would be taking a composite. You can, for example, take all of the time, but only some of the geographic extents. And each geographic extent, you could create the composite section and then stitch them all together. I'm not sure if that quite makes sense, but that's the idea. Instead of taking a composite of a whole, you might take a composite of pieces and stitch those pieces together. So here's an example of why you should use Dask. Suppose we're trying to analyze a large area like Lake Volta. Let's try to load the green and square one bands to calculate MNDWY, which is a water index. So we're trying to identify where the water is. First, we'll try to load without Dask, specify the product, latitude, longitude, time, measurements, group by solar day, and for this product, we have to specify the output CRS and the resolution. The star at the left indicates that the cell is running, we're scheduled to be run. In this case, it is running. But it fails. Running the cell to print the content of the loaded data, the cell at the bottom that says data, shows the notebooks were started. The cell number is 1 and the data variable is not defined. Sometimes you'll see memory errors in these cases. In this case, what ends up happening is that the cell running the load simply stops and the notebook restarts silently. Let's try again with Dask. To use Dask, we specify Dask chunks in our load. For now, we'll use Dask chunks is equal to a dictionary mapping every dimension to a number. That number is the size of the chunk. So every chunk, every piece of our data set that Dask has is going to be of size 5 on time and 2000 in latitude and longitude. So in this case, the notebook does not crash. We run it and we can see here in the load, the only difference, so we specify that Dask chunks parameter. And the data when we print it has the data we want. 9,663 latitude, 4,988 longitude, and 110 time slices. Now let's load data for Lake Rukwa for January and February of 2017, and then create a geomedian composite, and then calculate MNDWY again. We'll measure how long it takes to do this on the sandbox with 2 processors and 16 gigabytes of memory. And here on the right, we have a showing of exactly where Lake Rukwa is, how big it is compared to Tanzania. Quite large, quite large. So in running without Dask, the operations were actually fairly quick. It took 1 minute and 50 seconds to complete, 110 seconds. When running with Dask, these operations took 1 minute and 13 seconds to complete, 73 seconds. Now here what we can see is the difference is that Dask chunks is specified again, same values. But also at the very end, we have the data composite we call compute on it. And we'll talk about what compute does and other ways to work with this Dask setup. So in this case, that's about a 50% speed up on just a 2 CPU machine. And you should see even more of a speed up on a larger machine. All right, so how large of an area can we process without Dask? When do we actually have to start using this? Well, on the sandbox with 16 gigabytes of memory, loading 2 Landsat 8 bands, which is an important number because it's typically the number of bands we need for indices. NDWI needs it, MNDWI, think of a few more. So for Nairobi, Kenya, it's about 0.212 square degrees of the area I selected here. I probably could have optimized a little bit more, but that consumes about 1.2 gigabytes of memory. In contrast, if you load 2 Landsat 8 bands for Aberdare National Park to the north, about 0.4 square degrees, you'll get about 12.6 gigabytes. So for the sake of brevity, I'll just have to say that it doesn't quite scale linearly, the amount of memory, the area you're loading. And that's a bit of a complexity with how the data is stored, but just know that the area is more important than the time. So larger and larger areas will consume significantly more memory than depth of time. So in this case, if we loaded all the data for 2015 through 17 specifically, this is 3 years of data. For Aberdare National Park, 12.6 gigabytes, and that leaves a little room for any other data. And it's quite easy to fill up what's left there. I mean, you only have 3.4 gigabytes left, and that's for everything else. So how does Dask work? It improves performance and allows processing of large memory data by breaking up into smaller chunks and processing them in parallel where possible. But there's also concepts of lazy loading, as it's called, and task graphs, which we'll discuss next in that order. So first with lazy loading, a standard load will only complete when all the requested data is loaded into our dataset object, returned from the load. In contrast, a load using Dask will complete, the cell will complete very quickly because the data is not loaded when load is run. Instead, a plan to load the data is generated and stored in the dataset. As shown below, data variables in a printed dataset, not using Dask, top here, the one that says standard on the right, has its values printed. In this case, we see a lot of negative 9999, but whatever the value may be. In contrast, when using Dask, as shown on the bottom, the Dask variables are shown as dask.array with some of their qualities in angle brackets, in this case, chunk size. So mostly a dataset using Dask can be operated on just as any other. But instead of applying immediately as normally, operations create plans that will run when instructed. So the plans run on top of the plans. A plan to load, you might then run NDWI on, MNDWI, take a composite. Those are plans that run on top of the existing plans. So you're essentially layering work to be done. The planned operations can be executed by calling persist on the dataset, storing the results in the Dask cluster. So persist will keep your Dask objects. It will keep it working with Dask. All the benefits of Dask. Alternatively, a plan can be executed and its results stored in the notebook Python environment directly, not Dask, by calling compute. That will give us a result the same as if we had not used Dask. It stitches everything together. We used compute in our previous example using Dask to calculate MNDWI of a composite of Lake Rukwa. And that was here. So that would be the same result. It would be the same appearance, the same qualities as if we had not used Dask. So let's show how quickly Dask can create its plans. Let's run the Lake Rukwa Dask workload again without calling compute. So in this case, we can see Dask chunks is specified, but at the bottom with the data composite, compute isn't called. Simply the data composite is printed. It took 110 seconds to run the workload we had previously with 2 CPUs to actually do all that work. Here, it only takes 0.743 seconds to plan it. As we can see down at the bottom, the wall time is 743 milliseconds, 0.743 seconds. So it's less than 1% of the time to plan compared to the time to actually operate. As we mentioned previously, the plans Dask creates are called task graphs. The example below shows a task graph to load a red band. Here, there are 4 chunks, and we can know that because at the bottom, we have 4 boxes, and those are the origins of the data, right? It's what we're loading from. And the middle piece is the circles, DC load red. These are the actual operations to load that data, to format it into X-array. Or actually, it's NumPy. We'll see it on the right. We'll note on the right. And then the end results at the top with the numbers, zeros and ones, those are the chunks, the end chunks, the end results, where it's storing the data. So a chunk is a data structure. Specifically, it's called a NumPy array that contains a smaller part of the data being worked on. So without Dask, normally we have NumPy array. The whole thing is a NumPy array. Every data array, every data variable, like red, green, blue, it's a NumPy array. X-ray manages them. But in this case, the only difference is that we're using Dask to create chunks of these NumPy arrays. So here's another example. This shows loading red and near to calculate NDVI. Again, there are 4 chunks here. So this task graph works its way from the bottom to the top. First, it loads red and near, and you can see the 4 columns roughly. We load red and near, and then do some addition and subtraction in calculating NDVI and a division. And that's our result. So how do we configure Dask in our notebook? As we've seen before, you could actually use Dask without doing this, but we'll see in a bit the reason you would want to do this. This allows us to monitor Dask. It allows us to configure how Dask runs, if we so desire. So to configure Dask for a notebook, run create local Dask cluster provided in dafricadask.py in the scripts directory. And to clarify some of this information, as we'll say later, this is actually explained in a notebook. This is provided in a beginner's guide notebook on DE Africa Sandbox. But we'll mention that later. So an example is provided to the right. Here we see we're calling create local Dask cluster. And this creates a local Dask cluster which uses the resource of our sandbox environment. So what we're running on in the immediate. We can see the client and the cluster printed out. The cluster is the actual cluster doing the work. And the client is an object we can use to interface with the cluster. And this matters whether the cluster is local or some kind of remote cluster. All right. So we might want to monitor this. And that gets back to what we said before about why we'd call that create local Dask cluster. The reason you want to configure it that way, calling the function, is that you can interface, you can have means of seeing information about this as it runs. So the Dask cluster can be monitored through something called the Dask dashboard. One way to open this dashboard is by clicking on the dashboard link in the output of the cell that runs create local Dask cluster, as shown below. So as we saw before, there was the client and the cluster. In this case, we have the client here in the bottom left. Client has a scheduler and a dashboard. The dashboard link, you would click, and you would see something like on the right, information about your cluster. There are tabs at the top you can click for more information. The default will show you the amount of memory consumed or bytes stored in the top left, any processing tasks on the right, a stream of tasks, and the progress of any currently executing tasks. In this case, we can see the Dask icon is orange and yellow. It looks like the bow of a boat, I believe. So you can click buttons on the right here to add dashboard tabs to a new pane on the right side of the Jupyter Labs interface. And what we'll be focusing on here are these buttons: progress, workers, and graph. So in this case, the top tab on the right is the progress tab. It shows the count of every task to run and the number of them that have been completed. There are also overlapping color-coded bars that show numbers of tasks, the status of the task. In this case, the statuses aren't very complicated. To be more specific, here we see DC load red, green, and blue, and dataset. Dataset is actually the process of stitching together, combining, really, or writing to one shared area, I guess you could say, place for it to write the data as it's obtaining the data, as it's loading the data in separate chunks. So DC load red, here's load 1 of the 4, blue 3, and green 2. The rest need to be scheduled. But we can see that dataset has 4 scheduled, right? But 1 is completed. That is, 1 chunk is done, and that 1 total chunk, collective chunk. And you can see that red, green, and blue all have at least 1. Red has 1, green 2, and blue 3. which means we should be able to have one done, and we do. We can see here the data set has a lighter colored piece of the bar at the beginning, and it says 404, but 1/4 of it, the same amount as DC load red, is highlighted in a lighter color. So that means that that chunk is done for all the parts, red, green, blue. Now the bottom tab is the workers tab. It shows the CPU and memory used by every worker. In this case, we can note that it says total 1. That means that there is one worker, the worker namely is the environment, our local environment, with 2 threads. So that matters because if you had a cluster of machines, like let's say one day you scale up to a large cluster because you have a very large job to operate on. In that case, you would see multiple records. Right over here, you'd see total is some number, and maybe they would have different numbers of threads for different reasons. And there are some cases where you may even have the number of workers equal to the number of threads, even though you're running on one machine. But it's beyond the scope and simple enough as it is. So the tab on the right here is the graph tab. It shows the Dask task graph as it's processed in real time. The tab is interactive. You can pan around, you can zoom, and that can help when you have complicated workloads that are running and you're trying to debug something, which includes even your custom functions. You may write custom functions that can run on X-rays and then run them in Dask. You may want to debug what's going on or optimize. So as final notes, as we said before, much of this information is available in the Digital Earth Africa Dask Introduction Notebook. For more information and examples of using Dask in the context of the Open Data Cube. So that's in your sandbox environment. It's at Beginner's Guide 08, Parallel Processing with Dask. Also, you can see the Dask documentation at docs.dask.org, or just Google Dask documentation. As a final note, Dask isn't only useful for processing the imagery data that we have here, the raster data, pictures. It's also useful for processing tabular data. So if you're doing statistics on a pandas data frame, which is essentially a table, it's like a table in a relational database. You can think about it that way. Then you can chunk it up with a Dask data frame. It's the same interface. And this is the key to Dask, really, is Dask is using interfaces that we should be familiar with if we're using Python for our workloads. So if you were to choose to use Python to do statistical analysis, you would use something called a pandas data frame. In this case, Dask allows you to use a parallelized version with the same interface. So there's no relearning to have. And that's it. Any questions? I imagine there are a few.
Thank you very much, John, for this great presentation. As always, it's a pleasure to have you on board. Is it possible for you to share the PDF version of the same on the chat, please?
To share the presentation?
Yes, please.
All right, let's see if I can get it.
Yeah, PDF, that would be so great. Thank you so much. Otherwise, thank you very much, everyone, for joining us today. The presentation was on how you can actually make your processing quite faster. And I think by a show of hands, I've seen many of you who've been able to use the DA Africa platform. This is an opportunity for you to ask John questions. And if there's no question, it means everything was well understood. The presentation will be shared on chat. I know some people had technical challenges in joining and logging, so that's why we requested the presentation be shared with them. Then also from this forward, we can also ask any other questions that you might have for us regarding the DA Africa training, the materials, etc., etc. Also, I wish to acknowledge some people who joined us today. Mossad Hamad, how are you from Zanzibar?
Yeah, I'm okay. How about you?
I'm fine, thank you. Welcome, sir, to today's presentation. I see you're joined by your colleague Raya. How are you, Raya?
Yeah.
I think she's also okay. Very good progress with your students at State University of Zanzibar on the DA Africa training. Thank you so much. And take our greetings to Kairia. Thank you so much. I'm also joined by Stephen Corey. How are you, Stephen Corey, today?
Hello, Kenneth. I'm in a bit of a noisy place. I don't think I can be able to talk, but I'm following
Thank you so much.
keenly. I'm
Thank you so
traveling
much.
at the moment.
Thank you so much, Stephen. Thank you so much. No problem. Okay. We're also joined by Mohammed Kaba. Where are you calling us from, sir?
Alors, bonjour, moi c'est Mohamed Kaba, je suis de la Guinée-Conakry.
Tonpei, DRC. Bonjour, Mohamed.
Oui, bonjour, vous allez bien?
Ça va bien. Ton pays, Sénégal ou DRC, Congo?
La Guinée.
La Guinée. Ah, ok. Bienvenue, Mohamed.
Merci, merci.
Guinée-Conakry, Guinée-Bissau.
Guinée-Conakry.
Ah, ok. Merci beaucoup.
Ouais.
We are also joined. Yes, John.
Oh, sorry. Ken, I'm sending the presentation through WhatsApp, but if there's an email chain I need to send this to, if you could just forward it to me so I can see what who all the contacts are. I need to know the contact information.
You can just forward to me or Edward, then I'll be able to share.
All right.
Guys. Sounds good. Yeah. Let me give you the correct email. Thank you very much for making it very early morning for you.
You're welcome.
We are also joined by Joyce Siondu from Kenya. How are you today, Joyce, and how is experience with the Africa? We also joined by, I think today we had challenges with the internet connection. This is joined by someone called Mark on your computer. Are you able to hear, sir? Okay. We're also joined by Malka Uni from Ministry of Food and Agriculture in Ghana. Welcome very much, Malka. We're also joined by Nasa from Comoros. How are you?
Hello, everybody. I missed last week's session, unfortunately, but again, the presentation are of still a good quality of presentation. You heard me?
Merci beaucoup.
Merci beaucoup.
Really. We are also joined by various persons. Edward, do you have anything for us today? Edward Former.
No, again.
Thank you very much, Edward. Also wish to get more feedback on what, so a few items is that you have been able to use the DA Africa training material. Is there any feedback on the training, or are some of you not aware of the training materials? So at least some of you are not able to join because of the internet connection. Some of you have joined us today. Also, we're very grateful for the progress so far. And the presentation from John was very, very informative on the Dask material. Maybe some of you who've not looked at I can just take you through our website as we wait for the share the slide. So this is the new DA Africa website, and here you can see how you can access the platform, the links, and including the training. Also, I wish to draw you to this area of activities, more specifically the blog. If we're able to work with you, we can develop a use case which you can actually showcase right here. This is an example of a use case on the farming with agriculture. This is Stella. We also had another use case with Stephen Corey, who's in the call, showing some crop phenology mapping. So there are many possibilities. That is what I wanted to show you, how we'll be able to work together with you. And also you have our contacts with Edward. And I'm sharing the presentation from John on the chat so that you can follow up on this Dask. At this moment, I wish to ask if there's any question for us or to us that we can answer today. Yes, sir. Yes, Charles.
Thank you so much for today. I think I have seen something new and I'm so happy about it. The presentation is very informative, very informative, and I wish I'll have time to go through. The little concern is because some of us are very busy and we happen to get a little time to really sit and go through. I want to find out from John or from your end if there is going to be a really practical use of the interface where a practical question will be put in place. They will follow the Dask. You see that today's presentation has been more or less like a tutorial theory based. Maybe there will be a simple data set where it's going to be interactive. We'll be following John through the hands-on real life data or something like that. So help us to quickly memorize or maybe have a mental picture of how it really works. But I can see that most of us from this part of our end where our machines are not so sophisticated in our high end, John's presentation is going to help us to at least make use of the limited resources that our computers are having. For example, my machine I'm using now at times will be very slow. So I could see that John's presentation will be a very good resource for me to make good use of my limited resource that I have. And this is my little concern. Thank you so much for this opportunity. And I'm so grateful once again.
Thank you very much, our brother from Ghana Statistical Service in Ghana. This is well received. Having that we have the presentation and we'll have a practical session together in one of the live sessions. This is something we can organize. So we can organize to make the presentation to be like everyone is trying to look at least following through. This is a very good idea. Thank you so much, Charles. And we've noted that from our side. Any other feedback to us? Thank you so much. So if there's no feedback, will you be able to join us? Some of you will be able to join us next week. Edward and myself and the team here are very grateful. We'll try to organize a topic. So would you have any topic for us that is of interest? This would be very good as we take an assignment from you. And also we could also have you also present some of your use cases next week. So to